Hello friends, welcome back to my channel. Today I'll discuss about MVA method for calculation of fault current. So here the single line diagram has been shown for a 132 by 33 kV substation for which the source fault MVA of the source is 1000 MVA and two number of 80 MVA 132 by 33 kV transformer are connected in parallel. Percentage impedance of each of the transformer is 12.5%. So in this video, I'll discuss about how the MVA method is used for calculation of fault current for particular bus. So MVA method is very easy method for calculation of fault for a particular bus. So since the MVA capacity of each of the transformer is 80 MVA and percentage impedance is 12.5%, you can easily calculate the fault MVA of each of the transformer, which is nothing but MVA capacity divided by PI. So which comes as 80 divided by 0.125, which is equal to 640 MVA. Okay. So our purpose is to calculate the fault current at 33 kV bus. Since two number of transformer are connected in parallel, the fault contribution which is connected in parallel will be added up or summation of each of the unit. Okay. So here 640 MVA is the fault MVA of each of the transformer, which is the parallel combination of two number of transformer. So equivalent fault MVA for the two number of parallel transformer is 640 plus 640, which is equal to 1280 MVA. Now source MVA, which is connected at a 132 kV bus, is 1000 MVA. We can easily calculate the three-phase fault at 33 kV bus, which is parallel combination of 1000 MVA and 1280 MVA, which comes as 561.4 MVA. Since the fault current, fault MVA at three-phase fault for 33 kV bus is 561.4 MVA. So fault current at 33 kV bus is 561.4 divided by root 3 into voltage level, which is 33, which comes as 9.822 kiloampere or 9822 kiloampere. So it is very easy method for calculation of fault current for particular bus. Now we'll verify the fault current at 33 kV bus by means of the common base method. So here the source MVA, which is given at 132 kV bus, is 1000 MVA, and source voltage, which is 132 kV. Number of connect transformer which is connected in parallel is two number, and MVA capacity is each of the transformer is 80 MVA, and percentage impedance of each of the transformer is 12.5% or 0.125 per unit for 80 MVA base value. Next voltage level is 33 kV. We want to calculate the fault current at 33 kV bus. So let us consider the base MVA as 100 MVA. So we can calculate the value of the base impedance at 132 kV voltage system, which is nothing but kV square by MVA. That is 132 square divided by 132 square divided by 100, which comes as 174.24 ohm. So we can easily calculate the value of the source impedance, which is given by kV square by MVA. Okay. So here it is fault MVA is known as 1000 MVA, and voltage level is 132 kV. That is the source MVA is given by 132 into 132 divided by 1000, which is 17.424 ohm. So we can convert the source impedance in terms of per unit value, that is the uh, source impedance divided by base impedance. That is 17.424 divided by base impedance is 174.24, which comes as 0.125. per unit. So the ZT, that is the transformer impedance at 100 MVA base value, since we have considered the base value as 100 MVA, which is percentage impedance, that is 0.125 into 100 divided by 80, which comes as 0.15625 per unit. So since two number of transformers are connected in parallel, the equivalent ZT comes as 0.15625 divided by 2, which is equal to 0.078125 per unit. So ZT total impedance, including the source impedance, that is equivalent impedance of the transformer plus source impedance in terms of per unit, that is 0.1 plus 0.078125, which comes as 0.178125 per unit. So we can calculate the value of the fault current at 33 kV bus for three-phase fault, which comes as 1 divided by total impedance, 1 divided by 0.178125, which comes as 5.614035 per unit. So the base current at 33 kV bus is nothing but the base MVA, that is the 100 MVA divided by root 3 into 33, which comes as 1749.598 ampere. So fault current comes as base current into fault current in terms of per unit, that is 1749.598 into 5.614035, which comes as 9822.302 ampere, which is same as that calculated in case of MVA method for fault calculation. So we can conclude that MVA method for calculation of fault is very easy method. It requires less computation rather in case of fault MVA, which is calculated in case of considering common base method. Now let us consider that instead of two number of transformer, there are three number of transformer of same capacity are connected in parallel. So in this case, for fault calculation in common MVA base method, the fault current comes as at 33 kV bus is 504.2 ampere or 11.5042 kiloampere. Okay. Now in case of MVA method, it is very easy. Now instead of two number of transformer, they are connected three number of transformer in parallel. So fault MVA of the parallel combination of the three number of transformer is summation of the each unit, that is 640 plus 640 plus 640, that is 1920 MVA. So the three phase fault at 33 kV bus is the parallel combination of the source MVA and the equivalent value of the fault MVA of the transformer, that is 1000 MVA parallel of the 1920 MVA, which is 657.534 MVA. Since the fault MVA at 33 kV bus is known, we can calculate the value of the fault current at 33 kV bus, which is equal to fault MVA divided by root 3 into 33, which comes as 11.504 kiloampere, which is same as that calculated by the common base MVA. So we can conclude that MVA method is very easy for calculation of the fault current for any network. Hope you like my video. Thank you for watching this video.